इसमें है यहाँ से कहीं से होगा।
I don't know why today it doesn't work. Try the other solution.
हाँ मैं भी कहता कि मुझे यही लग रहा था कि यूँ करना पड़ेगा आगे से कैसे यूँ ही होगा ना। अच्छा हाँ लेकिन मुझे लग रहा था कि वो डॉक्टर वेल्ली करके एक्सेस करे तो मुझे लग रहा था कि छोटे से बड़ा स्ट्रक्चर यूजली इसी तरह बनते क्या उसके डॉट ऑपरेटर सारे सेट कर दिए। हाँ लेकिन मैं उसको मिस कर रहा था बेसिकली जब आपने बताया कि डॉट वैल्यू को कर
Okay. So, hello everyone. I wanted to. We have not much topics left, but nevertheless, one that I wanted to discuss with you is to query data warehouse with SQL. As a particular example, you know the typical dashboard that we can do. Managers ask, for example, this is of course a hypothetical one, but this is the kind of thing that we need to produce for managers. And as you, for example, this is the example in SQL Server, but each of these there is an equivalent, for example, in Power BI. Each of these visuals that I have seen you here, we have 5 elements in this dashboard, 1, 2, 3, 4, 5. And each of these visual elements are associated with a SQL query, as you could see here. For example, each of those, this is an example of the first one in the left corner, mostly sales compared with previous year. So for example, in reporting services, you define your data source, which is up there, and then you will have 1, 2, 3, 4, 5, the 5 elements of your dashboard, and each of those is associated with a SQL query. So you need to be able to do complex things in SQL when you are analyzing when we are exploiting your data warehouse. Similar things that we are doing now in Power BI for the second edition of the book is the same thing, the same. This is actually Power BI. We have the same 1, 2, 3, 4, 5. Here the idea is that Power BI is a little bit more dynamic tool than SQL Server reporting services, because here we have, for example, what they call a slicer. A slicer means that I can do this, I can try to do this online. So, for example, by adding or removing things, your selections within your dashboard here on your slicer, the values are automatically updating, depending, of course, of what did you put on your queries associated to each of those visual elements. If we compare with, for example, here we have less. I mean, it's an older tool. There is a new update on 2019 and I haven't yet installed them. But the idea is, in any case, that you need to be able to query do hardcore computations in SQL. For example, just as a matter of fact, each of those elements here, you can define Power BI to access a data warehouse in SQL, but you can also use this to access a data warehouse using DAX, which is the recent language proposed for Microsoft for interacting with data warehouses. So for example, if I go, let's start from this, I have these elements, so these are DAX measures, percentage change sales, and then I need to have here the minimum value, the maximum value, the target value, so the minimum value will be here, the maximum value for this visual element will be here, the target value is 115%, meaning the manager asked to have a 15% increase of the sale for the last month. So each of those is an element or a query associated to this visual element. So let's go, for example, the definition of the so this is a DAX version with another language that I haven't shown you, but for example, in this case, the element that I'm showing in this visual element is percentage change sales. Let me go here, percentage change sales. This is the way that's say you need to divide last month's sales minus last month previous year sales divided by last month previous year sales. So I need to go to last month's sales. So this is the way to produce it in DAX. But the idea is the same in SQL. So we will, independently of which language you use for define each of those visual elements, you need to be able to access your data warehouse in queries. And so today's lecture and tomorrow's exercise will be around querying the data warehouse, in particular to do complex things in data warehousing with SQL. As you know, SQL is an old language defined in the 1970s, way before the data warehousing domain was exploited. As we have seen already in the advanced database course, the second chapter, temporal databases, SQL was not designed to do time-related operations, temporal things. Therefore, there were, in addition, it was not designed to do data warehousing neither, simple data warehousing. There is an extension which is called SQL OLAP, which is targeted to do this, at least propose some operators for doing data warehouse related things. This is the first part of the lecture. We will use these operators extension of SQL to do an example of queries or analytical queries on a Northwind data warehouse here that we have already seen. And then tomorrow we will have some exercise lab session about, I will give you another example of a data warehouse, and then you will be doing SQL query for this data warehouse. So let's start together with SQL OLAP. So as you know, the idea of a data cube, this is a pivot table in which you have products, customers, and then you are saying how much units or sales, I don't remember, sales amount we have for this product and this customer. So this is somehow that a multidimensional view of the information, and then of course we have total subtotals by customer and subtotal by products, and this is the overall sales. So this is a data cube. Of course here the way this multidimensional pivot table is not a relational model, and then how we can express at least this part, the base fact, is simply one element for each dimension and the overall. So this is the way to represent this part of the non-derived part of the data cube. And then we will going to see how we have already seen that all the other elements that are around the subtotals and the overall total, these elements here and here can be obtained through simple SQL queries. So that would be the base or the aggregation of the sales fact with these two dimensions. You can imagine that there can be many more dimensions. Here I'm already aggregating this, and or even we can do here a sum to if we have more dimensions, and then we aggregate only by one of these two elements, and then put a null value in the missing element, and finally do an overall sales amount without any dimension. So this is, we have already seen, this is the operation, what we can do with the roll-up and cube element. You may remember that the difference between roll-up and cube, if someone can remember which is the difference between roll-up and cube with respect to this set of values?
Cube shows you all the subtotals.
Cubes show all these, and which are the missing one with group by roll-up?
The last four.
You wouldn't see cube shows you subtotals for both versions, product key related to customer key and vice versa. So you wouldn't see those last three, or I guess last four, except for the 595 would still be.
So is this one in the final group by roll-up?
Yes.
Yes. Are this one in the group by roll-up?
No.
I guess it depends on which.
Yeah.
Depending on in which order. If you put product key, customer key, group by roll-up, product key, customer key, which one of these 1, 2, 3, 4, 5, 6 will appear? First product key and then customer key.
So you'd see 1, 2, and 3.
So if you say product key, comma, and then the customer key, you will prioritize these three. And then you will not have all in the other order. So that we see, that we already saw. What we didn't have time yet to see is that you can fix. Here we have the two extremes, but you can already have something which is called grouping sets. Grouping sets, instead of picking all either this or either that, you can explicitly identify which are the grouping sets that you are asking for. So if you are not interested in all the combination, you can pick the combination that you are interested on. Okay, so very simple. Here we are saying I want the group by product by key, then by product. So basically this is equivalent to this, if you understand. But you can pick the one that you want in the grouping sets. So yes, this is what we have seen. Now I don't know how many of you have seen, you have used this over windowing function in SQL. Yes, no, no one? So this windowing function is a very simple thing, and it's a sequential scan. It's a sequential, semantically, and then there will be optimizations internal for the database, but basically you are a sequential scan of all the elements of your table. Suppose that you started with here, and you are here at this position in the sequential scan of your table. For each of these, each time you are in an element, you can define a window associated with this particular line. and then you get to the next line, and then there is another window associated to each line in the table. You get the idea? So we have a sequential scan, but typically when you have a sequential scan, we have only access to the line in which we are now. And the windowing function, you can decide how many rows in front or after this current line you want to define your window on. So let's see how, why it is essential. What is a traditional problem in SQL when you are doing group by? When you are saying, give me the sales, sum of sales. Basically, when you have a group by function, you can only obtain in the group by the rows on which you are grouping and the aggregated values. You lost the information in this particular row. So the one very well-known usage of this window partitioning is that you can have the values of this individual line, and in addition have aggregation values over your window. And this window can even go through the full table. So you can compare the sales, for example, of this current employee with the overall average sales of all the other employees. You get the idea? So this is not possible without window function. If you want to compare your sales of this employee with the average, something which is a computation over the overall, or you can define your window that goes through all the table. You don't put constraints on the window. My window is the whole table, and then you compare me, give me the difference, how far is the sales of this employee with the overall sales of all the employees. You get the idea, having at the same time the individual value and aggregated value and be able to compare the two. Yes?
So is the window always going to be relative position, or can you put in select and where clauses into your windows as well?
We will see, but the idea, indeed there are restrictions, but the idea the window is relative to to the current row which we are thinking of. Give me the sales of this employee and the difference, how far are there from the average of the sales of all the employees, or all the employees in the same department, or all the sales from last month. So you fix the conditions on which you can vary your window, and you can compare it with the single row that you have in your hand. This is the main idea. So let's see an example here. You have product key, customer key, sales amount. And then you define for this particular line that you have in your hand, you define a window, this is the first, yes. You define a window, and this window over is the definition of the window. And you still have this in your left hand, you have your current row. And then for this current row, you have a product key. Okay, for this you have in here. For this current key, give me all the rows of the table with the same product key. Out of this, you can define, give me the maximum of this row that are here. So basically, in this particular case, you have a product key. We are partitioning, suppose that product key is product 1. Then my window will associate it, my window, you have currently analyzing this employee. You know which is the product of this particular employee. My window will be contained by all the employees that have this, including myself or not, depending on what you ask for. So we have this employee, you compute the maximum of all the sales for the same product key, and then this is the function among all the values in the window. You compute the maximum, and then you have one additional column. Yes.
How is this different from group by? Because group by you only like return you P1 and 105, one tuple, but here like you can get 3 tuples of P1 in this way.
Thank you. Yasmin, very well done. The idea is that you can do that in a group by, but you need another query. And then each basically you say, I have this employee, compute a select from inside. And if this is not very efficient to compute, but because if the SQL optimizer is not smart enough, take the first line and compute the aggregation, second line compute the aggregation, third line compute the aggregation. So this is a way to induce SQL to do a sequential scan and select at each row, select, probably there are optimizations here, order by P or something like this, but the idea conceptually is to have, in a sequential scan, have a window. And out of that, out of this window, you can produce whatever you want. We will see clauses inside the over subclause to define how we can define different windows. So let's see, we have, for example, then we can compare, look at this sales amount, this is for this combination, product key and customer key, this is the row value, and this is the window, of course, for, these are all the maximum, for all this P1 will be 105. The maximum for all P2 will be this. So we can immediately see which of these customer key has the maximum value for this product. So this is an essential thing. Window is an essential operation that we use continuously for OLAP queries. Let's see also we can add an additional order by. And then in addition, look at this, we have some kind of ranking or sub-ranking among the same group. So let's see, when you define a window, you can order, and then you can have top 3, or whatever ordering you need. There are 2 functions in particular, row number and rank. There are some subtle differences we will see just now. But look at this example. How does each product rank in the sales of each customer? So we have the same value, product, customer, sales, and then so we have one line here, and then we are, instead of product now, we are having customer 1, customer 1 here, and we are saying order by sales amount in descending order of sales amount. So basically we take all this value, we have sales amount here. Let's put 10, 15, 5 and 8. So basically we select these 4 when we are analyzing this element, this row. We select these 4 rows in the window. We order with this order 1, 2, 3, 4. And out of this, we say, give me the row number in the window. So we will obtain 1, 2, 3, 4. Okay for that? That will be the value that we'll obtain in for all the customer 1. That will be the first value, the second value, and the third value. So we can rank the values within the window. Now compare the values of this employee or this combination with a target value. Okay for that? The idea, of course, the difference between row number and rank, what would be according to you, to your intuition?
What is the function rank?
The treatment of equal values.
The
treatment of equal values.
Indeed. Suppose that you have 2 employees with 15 here. Which of both will be first in our row number? We don't know. It's arbitrary, depending on the scan. You are saying, I don't care. You will have the same values 3 and 4. It's unpredictable. So then there is the rank number, the rank function. Let me see whether we have rank here. I don't add. Yeah, this is an interesting thing I could add. Rank basically gives you a possibility to say, suppose that you have what rank is a traditional function even in Excel. How rank is treating ties, values with the same number. Any idea which are the two possibilities? Rank existing in many languages, even probably in Python. What are the possibility of the values of a rank function when there are ties like this? So we have 1, 2. There is no point in that. How do we? What can we do here? And let's have another 1, 5, 5. Suppose that we have 1 and we have 20. So we have 1, 2, 3, 4, 5. What will be the possible values we would expect for a rank function?
Whichever one it scans to first. So the one, as it's going through your SQL code, the top one would arrive before.
This is wrong number. Rank, we are saying I'm interested in having a secure, fixed number, a predictable number for the ranker. What are the possible values we could expect?
To be 335.
335, that will be one possibility, 335.
334.
Or 334. Depending of where these are, imagine in your, I don't know, your Formula 1 or Olympic game, two persons having exactly the same point, what will be the position of the next one? So this is the difference between wrong number and rank. They are flags which define whether you want 5 or 4 in this value. Moving average. What is the definition, intuitive definition of moving average, and why do we need moving average? No, not we. Why the managers need the moving average?
Because it can show you the trend to some extent, like how the average is changing in the data.
Yes, but the moving average have a more fundamental objective.
So it shows you the average from some window of previous time, and it's able to smooth out large changes.
The keyword I was expecting is smooth out. See, there are a lot of variations in this particular month. I don't know, because last Friday, which was Black Friday, I want to nevertheless smooth all these outliers. And how do we define a window, moving window, a window average? Look at this, the same idea, 3-month moving average of sales by product. So we have a product key, we have year, month, and then we have the sales amount, and then we have this line already there. Until here we have it's normal SQL query. What do we mean by this? We take the current row. Remember, your left hand has always the current row, and then you define a window in your right hand. In this window, you define take the same product and order by year and month, and then give me the two preceding. What is important here is that when we have here, this is the traditional problem for which SQL, and we will see how to solve this in SQL, was not thought at the beginning to manipulate the previous month or the previous 2 months. And then the issue is that there are no functions that go from, 1st January to 2012 to go to more. There are some tricks for doing. We will see that immediately. But you get the idea. We need to switch from a year or 2 or 3 months from the previous year, depending on which row you have here in your left hand. But the idea is the same. You are analyzing, look at this, in 10, suppose that you don't have sales before. Moving average will be 10. Next, so here how many we have before? We don't have 3, we have only 2 values before. Then of course we do the simple average between these 2. Now we have 3, now we can have the average of these 3 will be this value. Now we are here, 1, 2, 3. Then we do this average that will be like this. Here, again, now we have 3 and we have this.
So, sorry, actually, at that point, are you still, because you've moved into a different product key, are you still?
Sorry, maybe I was too fast. Yes, indeed, you are right. I'm moving for another product key. Indeed, you are right. So here is the first value for nice. Thank you for pointing out. Indeed, I'm moving to a product key. So here I don't have one, I have only one value. Here I have 2 values. Here I have 3 values, and then I always see 60, 50, 56 as average. Okay for that? So for the trick here is I already have this. I haven't told you how to obtain this year and month before, but we will see how.
Question, what's the row 2 proceeding? Row 2 means?
So you have your current row in a sequential scan in your left hand. And then you are saying my window will be composed of this value and 2 precedings. Okay? Yes. But we can also, another very traditional way to do is year to date. What is year to date? Why do managers need year to date?
So year to date would be from the beginning of the year until today.
Yeah.
And usually you need it because you might have metrics or some sort of goals for by the end of the year you want to hit something. So if you're mid-year and your goal, let's say you have a goal of hitting 300 and it's mid-year and you're at 150, maybe that's a good place to be. If you're at 50 and you're supposed to be at, you can start to see how are you performing over the year. I guess.
Yes, perfectly. Thank you for that. Let me see this particular example here. I have in this example monthly shipping cost to sales ratio. So you imagine an Amazon kind of web store in which of course you get the sales, but you need to have the percentage of the shipping cost with respect to the sales amount. And so you are saying I want to keep this is my target, my KPI. I want to have 5% of my total shipping cost, but I'm here only in this particular example, the database only goes until May 4th of one particular year. So I can already say until now my year to date shipping. Let's see the definition of this example. Of course, I have even a SQL query corresponding to that in where it is here. Year to date shipping cost. Let's go there. Is it here? How to obtain this? Not this. I will show you here. So this is the example. I will show it here. Sorry for this. Here, I have it here. The shipping cost would be like this year to date. Yes. So in my example here, I have this is we have a traditional sales fact. Can someone explain me what this query, the first query does?
So you have two tables, one is sale, one is date. You are choosing the largest date from the date table, or
current
the largest year out of the date table. You're choosing the largest month out of the date table. So that's basically you're picking, I assume today, or the date that you
this
have the
current
most
month?
recent amount of data.
Sorry?
current month.
Yes, I mean, I have sales, but I have sales until a particular date which is here. I don't have the full day now, so I need a join to obtain the real maximum date, the date of the last order. And then out of this date, so that would be the date of the master, the date of the last order, and then I obtain the year and the month. Okay, we are beginning to say how to extract years and months. And then out of that, I do, look at this, I'm doing some the sales for, I have already this month, so this month, look at this. I obtain for all the sales, I want to obtain the year and the month. Allow me to go a little bit before. I will show you already what I wanted to show you here. What I wanted to show you here is that somehow we need to compensate the problem that in SQL we don't have this year and month calculation. Oh, let me go. It's 5 or 6. This is DAX SQL queries. SQL queries. SQL. So look at this example of view. I need two views for obtaining this year and month that we have just said. I take the date table. I take the year for each. I need to somehow have a month table in my database or table or view to obtain this month and year. So how do I do? For each month, I will take the year 2011, for example, or 2018, and then for each of these months, I will obtain the month, and then I will obtain September, October, November. This is needed all over the place in the database. Each query, I need to show most numbers. Another thing that I always need to do is to obtain for each year and each month its previous month. This previous month, how do we do? So you remember the example I just showed you in this, where was it? Chapter 5 slides, okay, I was in another program. So you remember I have this year and month. I need to know which is the previous year and month. So I have already computed once and for all my data warehouse. And this is down here. Again, this is simple SQL. Try to explain me how do I compute for one particular month in my date table the previous month and the previous month.
What does the function lag do?
Yeah, good point. Lag, you have a window we haven't seen yet. You the next value in the window. There are lag and lead. No, sorry, lag is the previous one. We will see that immediately. Why do I do years times 100 plus month number? How do I see?
We make space for if you want to store in one variable both the month and the year.
So we convert these two in a numerical value. So what will be if we have January or September 2008? What will be the value of this expression? For the moment, let's see, we have January 2010.
So 2, 0.
And then the month, suppose that this is August. Okay? So this is a traditional trick even in DAX. a traditional trick to convert the year, month, and number into a single value. And then look at this. I say I have this year month table. So I have January 2010. Let's go here. January 2010. I order all my months in my data warehouse with respect to the same value. So if I have 2009, if I have 2009 and my previous value will be like this, two values before will be 2009-11. So this is all you have you remember here we have all the months of the database. Now I am converting all the months in the database in this numerical value, 2009 plus 12, 209 plus 11. So when I'm here, the lag function will give me the previous one. And the lag function of the first value of the database will be null. And the lead value for the last value of the database will be null. You get the idea? So now with this simple, then look at this. One we have this, I will have year, month, month name, previous month, divided by 100, previous month, modulo 100. What do I do here?
You divide the date and the month and the year.
So I just got this. That will be my year, and that will be my month. And then I have in a single table year, month, and previous year and previous month. So essential. This is even. I mean, when I was doing, in my previous version of the book, we did that within a query. But now I was trying to do the same thing here. And I also need it here because I need, in this example, year-to-date shipping cost. Suppose that I'm here on, this one. The last month sales to same month previous year ratio. My target is to have 150% increase at the end of for each month. Therefore, I need to have functions to immediately be able to have the same month of the previous year or 3 months before. All these month calculations are not done. There are no functions like this in SQL. There are some functions like this in DAX and MDX, but it's this is not rocket science. You define it once on your data warehouse, and then you have exactly the same functionality as you have in newer languages for data warehousing.
And for this example, is your dates table just containing all the years and all the months? So it's not generated off of when sales were made?
No, indeed, this is the traditional date I mentioned in a data warehouse. Of course, it need to contain the first day of your sales, but it contains typically 5 years from now.
Okay.
So we have a full. You don't need to modify this table every year. So we have 10 years from now, and then you add 3,000 more rows. Who cares? I mean, 3,000 more rows in your table. There will be no joins. Because there will be no joints with the sales table. So this is the problem, to minimize joints. So basically, with this, you are able to do a lot of calculations for month manipulation. So that was year to date. So year to date. Suppose, how do we define this window? We are here. This is my first value in my database. For this year and this month, I have sales amount. Year to date will be 100. There are no previous values. I started my company on October 2011. Year to date, this. Year to date, only 3. Now we started a new year, then we have this year to date, etc. You get the idea? So again, this is how do we define this? We have partition, product key and year. So we are saying when we are analyzing in particular this value, you have in your left hand P2 and 2011. Give me in the window all this value with in the table with the same P1, P2 and 2011. This is your window. And then you say, we have the same year. You order by month. And then you say unbounded precedings. All the values in the beginning of the window has no border before. You can, yes, the sum is then associated. You have here average or sum. Here is a type which should be average, of course. But in any case, all the aggregation function will be with the same, for the same window. Get the ideas? Yes?
Can you please read what is year to date? Just, I don't understand what is the last quote.
So year to date is, as Adam told the example, in my case, I want to obtain 50% of increase of sales for the end of the year. If you ask yourself this, the 31st December is too late, you cannot arrange, you cannot change anything. So year to date allows you to regularly verify how far are you for the current target, but only for the year, the current year. So in this case, I'm saying, what will be if this is you started your company in this month, year to date there are no preceding values. The next year you have already these two values and then you want to add it here. 100 plus 105 give you this value. Year to date you have here three values in the same year. So all these will be 35. Now you started a new year, we are only in January. You have only the values for January. In February you have the values for January and February. In March you have the values, suppose that we are not changing here, we have the same product. You will have the values for the same product and the same year, 3 months. So you are verifying if the situation does not change, how well you will be targeting your objective. You get the idea? Year to date, you say you filter the value and average or sum the current values of the year, of the same year. Of course, you need to restart it when on 1st of January. Okay for that?
Sorry, can you, the unbounded preceding, I didn't understand the unbounded piece.
So we are here.
Mm-hmm.
You remember that here in the previous example, you say two preceding. For I have one particular value for 1 month, I have two. My window is composed by this one and two previous ones. Here we are saying I have this value and my windows get all the values until the beginning of the window. Filippa?
Why do we use sum here and in the previous one average?
I mean, it was a typo. That should be, whatever function here, it probably, you can have first, rank, etc. So it's a typo between this and this.
It should be sum for year to date.
Or but you can, in any case, the idea is you can have whatever function, your aggregation function you want to put there, standard deviation, whatever.
Yeah. And so here you also didn't order by year.
A good question. Order by year. Does it make year is not here? Why is not here? Or I mean, so can we put order by year day or order by year, comma month? Does this change the value?
It won't change the value, but I just wonder your output is not possible that your output will be 2012, then 2011, then 2015.
The order by should be here. The order by of the output. You have an order by for the window, and then you can have an order by here for the result of your query.
So right now, the way it is, I mean, we got lucky that it
Yes,
showed up,
indeed, perfectly
but
stated.
there's nothing in your script that forces it to show up this way.
Perfectly stated. You are lucky.
Okay.
Yes.
If we only write partition by product key year, order by month, and that's it, will that pop up an error?
No, but which is the definition? What do we have if we remove by month? If we remove all this, what will be the value?
Every single.
Even suppose you are here, or yes here, you always have this one. You have all the values for this year. So you need to filter out the values previous to today, previous to the current row, to be more precise.
And then just back to the ordering, given that we have order by in your partition, is that forcing the output to be ordered by the month within my partition?
Within my partition, yes.
Okay.
You are forcing in order to filter out those that are later than my current month.
Well, I understand the math. I understand that the year-to-date math will work, but in terms of the view itself, am I also lucky that my months are in the right order? Is it possible that I see a 2011-11 and then a 2011-10, and all of my year-to-date numbers would stay the same that they are, but would the order, is there anything in your script that's actually forcing it to be ordered by month right now?
For the window definition, this is essential. For the how does these values in the output, I mentioned here indeed, probably for my next version of this slide, I will put an order by to be sure that order by product, by year and month.
Okay.
But for my window definition, it's essential to be by order. Otherwise, if I randomly, I can get, when I'm computing this value, I can get randomly this value because I didn't order. And yes, so that's all. So maybe we can have a quick break and then we start using these functions in a real context.
Is the Northwind
Yeah.
database, like Power BI dashboard, is that available online, or is that something that you've created?
I can give you. I was planning to do this to send you for tomorrow 2 databases in Northwind and another Footmark, so we can practice on your SQL Server. Or sorry, on even PostgreSQL will be easier. Now that we have PostgreSQL, all of you, it will be easier to install in PostgreSQL. You don't have to all the pack of SQL Server and the huge amount of megabytes in your hard disk.